Well, I'm back again. Here we are, Module 4, Lesson 11 on page 85 of your book. If you'll notice, I don't have an essential question today. Ultimately, this lesson is pretty much a review of everything that we have been doing thus far throughout the whole book. We're not learning any new concepts. It's just changing maybe the scenario that it's in. So normally I say let's leave the opening exercise for class, but we're going to do it today, right now. So here we go. How are each of the following percent applications different and how are they the same? Okay, so Sylvia earns 10% for each car sale he makes while working at a used car dealership. If he sells a used car for $2,000, what is his commission? Right, so commission just means how much money is he going to make when he sells this $2,000 car. So it says that he makes 10%, right? So there's my percent. And we know what the whole is in this group. We know that he's selling the car for $2,000. What is his commission, right? His commission would be the quantity. It's not part, it's going to be a quantity. So this is very much like what we've been doing, right? Quantity is equal to the percent times whole. So we're just going to drop everything in. So the quantity, his commission, we don't know, is equal to the percent. Well, I've got to change 10%, remember, is 0.10. So 0.10 times the whole, how much is he selling the car for? 2,000. So either move the decimal point over one time or grab your handy calculator and you find out that his commission is $200, right? He makes $200 on commission for just this car. That's why the salesmen are always coming after you saying, hey, I can help you, because they're going to make money. All right, Tu's family stayed at a hotel for 10 nights, right, on their vacation. The hotel charged a 10% tax per night. How much did the family, or how much did they pay in taxes if the room was $200 per night? Okay, so we have, $200 for every night, $200 per night. And how many nights is he doing this? He's doing this for 10 nights, right? And there's a 10% tax, which means we're going to multiply by 0.10. And then you can grab your handy dandy calculator, type these all in, or you could say, hey, 10 times 0.10, right? Really, this is the same as 10 times 1 over 10. Well, those two are going to cancel each other out, and you are left with just $200. They paid $200 in tax. You're like, wow, that's a lot of money. Yeah, well, I also spent $2,000 on this vacation just at the hotel. So vacations aren't cheap. All right. Eric bought a new computer and printer online. He had to pay 10% in shipping. Right? The items totaled $2,000. How much was the shipping? Okay, so again, this is going to be another one of those finding the quantity, right? What's the shipping cost? The quantity, don't know. So 10%, 0.10, times the $2,000 on the computer. And what was the shipping cost going to be? That's the quantity, and he's going to pay $200 in shipping. Noticing a trend here? Anyone want to go out on a limb and tell me what letter D is? All right. Selena had her wedding rehearsal dinner at a restaurant. The restaurant policy is that gratuity, like the tip, is added in the bill for large parties. Her father said the food and service was exceptional, so he wanted to leave an extra 10% tip on the total amount of the bill. If the dinner bill cost $2,000, how much did her father leave as an extra tip? All right, so again, we're going to have $2,000, and our tip was 10%, so times 0.10, right, because 2,000 was the total. How much was the tip? Tip was, you guessed it, $200. So what did you notice about all these problems, besides the fact that they all were the same answer? Okay, what do you notice? We'll talk about it when we get to class. All right. Show all your work. A calculator can be used for these calculations. Here we go. The school board has approved the addition of new sports team For your school, the district ordered 30 team uniforms and received a bill for $2,992.50. The total included a 5% discount. The school needs to place another order for 2 more uniforms. The company said the discount will not apply because the discount applies on orders of $1,000 or more. How much will the 2 uniforms cost? Okay, so what we have is we have got our total, right? We know what the total is. We do not know, what we don't know is how much 1 uniform costs. Okay, we also know that we had a 5% discount. So if we have a 5% discount, 100% minus the 5%, that means I paid 95%. Right, because this is the discount. So since I have 100 minus 5, I have a 95% that I'm actually going to pay. So what I can do is I can, and by the way, this is part, I've got to figure out the whole. So I've got my part, or quantity, is equal to the percent times whole. So I'm just going to drop things in. $2,992.50 is equal to, I'm going to use the 95%, 0.95 W. I'm going to find how much is 1 whole. All right, so I'm going to divide both sides by 0.95. And I'm going to find out that without the discount, right, without the discount, it would have cost them $3,150. Okay, well, that's not 1 uniform. That's how much the whole thing would have cost. How many uniforms did they buy? Right? They bought 30 uniforms. So I need to take the 3,150 and I'm going to divide it by the 30 to figure out the cost of 1 uniform. Okay? So grab your handy dandy calculator. 3,150 divided by 30, and I find that the price is $105 for 1 uniform. I don't want to know the price of 1 uniform. I need it, but I need to buy how many? I need to buy 2. So I'm going to double this. So it's going to cost $210 for 2 uniforms. Okay? All right. Continuing with this scenario, the school district does not have to pay 8% sales tax on this. Estimate the amount of sales tax they saved, right? So if they had to pay the sales tax, how much would it have been, basically? And notice it says estimate. Okay, we're not talking the exact, but let's just try and define an estimate. So since it says estimate, I'm going to do a little rounding first. I know that $2,992.50, it's really close. No one would say, oh, this is exactly how much. They're going to be like, yeah, it was about $3,000. Okay, this is the approximate or about symbol. Okay, it's actually approximate. It's the approximate symbol. So it's approximately $3,000, and it says that they are paying, or would have paid, 8% sales tax. So let's just take our 3,000 and multiply by 0.08, right? And find out how much our tax would have been. The tax, when you grab your calculator and do this, you find the tax would have been around $240. So that's how much they saved in taxes, because schools don't have to pay the tax, right? If you had to pay it out of your own pocket, you're in an organization or whatever, they have to pay that tax. That's how much they would have had to have paid. All right, a student who loses a uniform must pay a fee equal to 75% of the school's cost. Okay, you're going to have to pay 75% of the school's cost for the uniform. All right. For a uniform that costs the school $105, will the student owe more or less than $75 for the lost uniform? Okay. Are they going to pay more or less than $75? So if we just take 75% which is 0.75. Now it says how much we're going to pay. We're not how much they're going to deduct off of it. So this one is a straight, we're going to use that number. So 75% of the 105, because that's how much the uniform costs. And we get, what do we get for an answer? Let's grab our handy dandy calculator. And let's see, 105 times 0.75. I get $78.75. So they're going to pay more, right? More than $75. Okay, letter D. Write an equation to represent the proportional relationship between the school's cost of a uniform and the amount a student must pay for a lost uniform. So U is the uniform cost, S is this amount the student is going to pay. So the student has to pay what percent? 0.75, right? 75% of what the uniform costs for the school, right? What is our constant of proportionality? Ooh, there's a term we haven't seen in a while. Remember, I purposely misspell the word constant to help me remember that constant is the letter K. What is my constant of proportionality? It is 0.75. This means that the student is paying 75%. Right? They're going to pay 75% of it. All right, let's go over to page 88. New problem. A taxpayer claims that the new sports team caused his school taxes to increase by 2%. Write an equation to show the relationship between the school taxes before and after a 2% increase. Use B to represent the amount of dollars the school tax before the 2% increase, and T to represent the dollar amount of the school tax after. All right, so T is the amount that the taxpayer is claiming to be paying, right? And it's 2% more, an increase. So that's like a markup. I want you guys to that's like a markup problem that we did the other day, which means we're going to take 1 and add it to the amount, 0.02. Okay, right? So this is really 1.02 times what it was before. I don't know what the person was paying before. It's all based on the size of the house and the property taxes. So that's what we're going to base it off of there. Now we're going to take that equation and we're going to fill in our table here. Okay, so let's see. Let's drop in 0. So if I had 0 taxes before the tax increase, I still pay $0. Woohoo! If I had $1,000 in taxes before, I type in 1.01 times 1,000, and I find out that my tax is now $1,020. If I had paid $2,000 in taxes before, I am now going to pay $2,040. Well, let's suppose right now I'm paying $30,060 in taxes. That means before I was paying only $3,000 only. And if I am currently paying $6,120 after the taxes, so I take $6,120 and I divide by the 1.20, I will find out that I used to pay $6,000 in taxes. All right, taking that data, let's make a graph. All right, take that data, let's make a graph. So before taxes, right, the taxes that we had before are going to go down here because that is my, before is my independent, and the after tax okay, is going to be my dependent. And if you are thinking ahead here, we know that we could probably just count by thousands. 0, I didn't leave myself much space, did I? 1,000, 2,000, 3,000, 4, 5, and 6,000. Probably could have spread those out a little bit, but that's going to work for me. Now, if I'm really smart, I'm going to think about what I want to count by on my y-axis. So I'm actually going to count by 1,020. 1,020, 1,020, 2,040, 3,060, 4,080, 5,100, 6,120, right? And so on and so forth. Don't need to go any further than that though. And now I'm going to place my data. So 0 was 0, 1,000 was 1,020, 2,000 was 2024, 3,000 was 3060, and 6,000 was 6,120. Okay, I know those for sure. I'm not going to connect them. Don't know if I can. We'll discuss that later. Is this proportional? Explain how you know. Is it proportional? Remember way back? This is, isn't it? This is a proportional relationship because, give me the two reasons why. It makes a line and it goes through 0, 0. And because of that, we know it's proportional. All right, letter E across the page. If you need to, hit pause, but I'm going to move on. Letter E. So what is the constant of proportionality in this problem? So the constant of proportionality, what did we multiply by every time? Well, it's 1.02, right? It represents the total cost with tax, right? It's the 100%, the cost of the tax on your home or on your property, and then that 2% increase. Okay, so it says, if the taxpayer's school taxes rose from 4,000 to 4,020, was there a 2% increase? Justify your answer using a table, graph, equation, whatever it is. So, is this? No. It's not a 2% increase. If you go back, look across the book here, across at the table or on the graph, and if we could fill it in, right? Especially if we go back, I'm going to flip over a second. If we go back and we fill in the dots for 4,000, right? Wouldn't the dot be there? So that dot there is at 4,080. So on the graph, right? On the graph, because on the graph, 4,000 becomes 4,080, not 4,020. So no, this guy is wrong, this taxpayer is wrong, it was not a 2% tax, it's in fact less, right? This is less than 2%. Because if, again, I'm going to flip over to the other page here a second, if you look, 4,020 would have been like right about there, okay? So this is what the tax should have been, and this is what the tax really is, okay? So it is below that, so it is less. All right, top of page 90, we're almost done. Let's take a look at 3 here. Okay, the Sports Booster Club sold candles for a fundraiser to support the new team. The club earns a commission on its sales, which means it receives a certain percentage of the total dollar amount sold. If the club gets 30% of the money from the candle sale, what would the club's total sales have to be in order to make at least $500? Okay, so this is what I want, right? This is my quantity. I've got my 30%, there's my percent, and I want to know how much should we have at the beginning, right? I don't know that, that's my whole. So if I write this out, I've got 500 equals 0.3 times the whole. So if I divide both sides by 0.3, I find out that the whole is about, right, $1,666.67 with rounding, right? That's how much they have to make in order to earn $500. All right, last one. Christian's mom works at a concession stand during the sporting events. She told him that they buy candy bars for 75 cents each and mark them up 40% to sell at the concession stand. All right, we want to know what is this new price, okay, and how much is the markup. So I'm going to kind of do these both at the same time. So I'm going to say N is the new price. New price equals N. All right, and so we know that it's a markup of 40%. Remember, when we do a markup, we do 1 plus whatever our percentage is as a decimal. So our markup is 1.4. How much was the original price? Right, that's the original price. So my new price is equal to 1.4 times the original, which is 0.75. So when I do this, I find out that I get $1.05. Okay, so the new price, they're going to charge $1.05. I've actually answered part B first. And the question is, how much? What is this markup? How much money are they making on this? I kind of did these kind of in a weird order, but that's just how my brain works on these. I do them sometimes in a weird order. So I'm going to take $1.05 and I'm going to subtract the 75 cents that they paid for it. So how much profit did they actually make? They made 30 cents profit. Or 30 cents in their markup. All right, you see where it says number 5 there? Yeah, we're going to do that later. So don't worry about that one right now. That's all that I have for you guys. See y'all later.